So imagine this. You're in a spaceship with your friends going for a little road trip somewhere off to go and see the North Star. Well, there's a good chance you'll have that one really annoying person in the backseat who just keeps asking, how far is it still to the North Star? Well, how do you find the distance from you to the North Star? One way astronomers go about this is they take the brightness of the star that they observe from where they are right now, and they compare it to the brightness of the star if they were right in front of it. You can think of you're putting your face right in front of a light bulb and it's super bright, whereas if you go further away, it's going to be a little bit dimmer. And this is how astronomers measure distance. So you're in your spaceship and you look at the North Star, and let's say you measure its 100th the brightness of the sun. Well, how do you find the other brightness, the true brightness of the North Star, without ever having been there? Well, fortunately, the North Star is a twinkling star. We call it a Cepheid. So sometimes it's brighter and sometimes it's dimmer. How does this work, and why is this useful to find this brightness? So the North Star is burning helium, and because it's very hot in the outer shell, some electrons of the helium are ionized. They leave their parent helium atoms, and the light inside of the star interacts with these electrons. It bumps into them, and it gets reflected back into the core of the star, so the star heats up. Well, if the star heats up, what happens is this. You have more electrons in the shell, because they were ionized, and more heat that is trapped inside. So as a result, the star gets kind of darker. No heat can escape. Well, what happens with things that heat up is, well, they expand. So now you have a big star, and heat all of a sudden can escape. Well, once the heat can escape, the star cools off, and it contracts, and the whole process starts over. What does this tell us about the brightness of the star? Well, bright stars tend to also be big stars. Now, I'd like you to think about two dogs, a big dog and a small dog, and they're going for a race. And just picture a small dog at the end of the race being totally heaping for air and having a heartbeat that's super fast, and the big dog is just kind of chill. And basically, you can think of a big star like a big dog. The heartbeat of a big star is going to be a bit slower due to lower gravity. Well, so if you look at a big star and the North Star, you look at the North Star and you see that, well, it takes 4 days to complete one pulsation cycle. That means that it has a total true brightness of 1.2 times the solar brightness. So now you've got your two brightnesses, and you can therefore compute the distance. So at the end of the day, you can confidently turn around to your friend in the back seat and reassure them that they ought not to worry because they've got a mere 433 light years left to go, and I hope that keeps them quiet for a while. Thank you.